Okay, so once again, welcome everybody to the webinar. In this webinar, I will present you how to quickly and simply integrate one of your own algorithm into an OpendTect attribute. So for this, I will after a brief introduction, in which I will talk about the algorithm we will use. We will go deeper in the subject and start creating an attribute. I will first start with some terminology that you will hear and see during this session, and after that we will start together programming the attribute. When this is finished, then we will build a simple user interface to go together with your attribute. And lastly, I will briefly show you how to use this program by setting up a plugin and then later on using the attribute into OpendTect. So the example algorithm I've chosen for today's session is the region attribute. This is a simple attribute that can be used to make the interpretation of structures easier. As you can see here, we have some seismic data, and here this is a view of the region attribute. And as you can see, the structures are easier to follow. So let's go ahead and see what is the algorithm actually doing. Each sample of the trace will be compared with one sample above and one sample below it. If it has a higher value than the sample below and above it, the sample is located on or near a positive peak. Thus, we will just give it a 1 as output. All of the samples will be made zeros. Of course, the same can be done for negative peaks. Consequently, the sample must be smaller than the sample above and below it. And of course, it is also possible to display not only the positive or negative ridges, but also to combine them and create a new attribute. So let's go a little bit deeper in the subject and start with the attribute creation. Well, first of all, as promised, some terminology that you will see all over the place when we start programming. So first of all, you will see those attribute desk. In fact, this is the attribute description. What do we mean with that is the description holds the number and type of all the attribute parameters, the number and type of the inputs, and again, number and type of the outputs. So wait for the description. And you will also hear about the attribute providers. In fact, every attribute is a subclass of those providers, which means that each of the attribute can thus be used as input for another attribute. This is why we call it provider. And of course, we will also talk about the attribute engine, which does all the handling. That means that it reads the description and sends the parameters and data to the attributes, and it manages all the attribute computation. So a little bit of insight into the attribute specification. What are the elements that specify an attribute? So as I said, those are the parameters. Any kind of parameter from the booleans to strings or enumeration parameter. We also need some input information, not only the place where we will get the input data, but also the type of the data. It can be important to specify, for instance, whether this input is coming from steering data or maybe some velocity cube. And we also hold in the description the type and number of the outputs. So here we can start with the programming, and there are actually only a few functions that you really need to code. What I mean with that is that those few functions are inherited from the parent class provider, and you need to code them to build your own your new attribute. I will present all those functions one by one and tell you the link between those functions. But the interesting thing already is that you can see that out of those 6 important functions, you already have 2 that are either automatically installed or optional. So that gives you an idea of how easily you can start programming. So I will start with the first function, but let me just close the presentation. You can see it here in smaller size, and I will start with the coding itself. So we do our programming in C++. You might notice it while looking at what I present, and here I have here on the left the header file of the attributes, and on the right I have the source code of the attribute. Actually, I did just create a basic file which is almost empty, and we will just fill it up together so that you will understand step by step what you need to do. So first of all, the init class. The init class just initializes the attribute, and it sets the parameters, it sets the number of inputs and outputs and their type, and it adds the attribute to the factory. So here I just start to code my attribute. So I've just started the init class function. And we will start with defining our parameter. Just so what do we want to specify as parameter? Most of the time you will of course need to specify the type of the parameter, so it can be anything, float, zgate, or int, boolean, whatever. It's eventual default value and limits, and whether the parameters are required or not. Here, in our case, we only have one parameter. This is an enumeration parameter, which will say whether we want to compute the positive ridges, the negative ridges, or a combined version of those two. So here we go with the parameter. So as you can see, this parameter is of type init. I just created, and I had one by one all the type of the enumeration, minimum for the negative ridges, maximum, and extremes for both. And I had this parameter to my description. This is the only parameter that we have, so we can just move on and start defining our input. Oops. And start defining our input. So as you can see, we only have one input. So this is relatively easy. We just do description, we add one input, and we, in this case, have only one output. We just add one output. And here it is, we have created the first important class, the init class function. The first important function, the init class. Let's just continue this way and go ahead with the functions we need to program. The next function you might hear of is the create instance function. You will just notice, if you look at any other attribute we have in OpendTect, to the code I mean, that the create instance function is always present in the header file, but you can never recognize it as such in the source code. This is because this create function is a call to the constructor, but to make it easier for you developers to integrate your own attributes, each time we figure out that something can be made easier for you, we integrate the difficult parts into a specific macro. So in this case, to have your create instance function and the call to the constructor, I just have defined this macro, and as you can see here, the only thing you need to specify and that changes from one attribute to the other is the name of the attribute. So this create instance function will just call the constructor. So let's just have a quick look at what the constructor will be in our case. So in our case, as you can see, we have here a constructor which is almost as simple as it could be, I would say. So as you can see, we give the constructor the description. And of course, remember that our attribute is a subclass of the provider, so that's the reason why you see it here. And the only thing we need to do in the constructor is to get one by one all the parameters from the description to just be able to use them afterwards in the computation. So in our case, we only have one parameter, which is the type of the reaching we will use. And once again, we have just set all kinds of macros to allow you to get quickly and easily all your parameters in. So here I have mget enum just to get your enum parameter, and you can think of any straightforward combination like mget bool, mget float, or whatever. I will later on in this presentation show you a little panel saying in which place of our code, of our software, you can figure out what those macros are and what you need to know to use them properly. And the next thing you can see here is that I just define a little variable that is a member of the class, and this little variable is an interval because remember our algorithm will use one sample above and one sample below. So here is the interval that we will need later on to specify this. So let's move on to the next function. The update description function is a function that you might need to use. It is optional. This function just means that in case the number and type of your parameters or outputs or inputs is depending on some other parameters, you can, while reading the parameter, change the number of inputs, their type, the number of parameters, their type, and so on. This is the reason why it is optional. In our case, we have a simple attribute. This function is of no use at all. We will just not program it today. That was just to let you know that this is possible and that this exists in case you have an attribute that requires it. Same thing for the get input output function. This function is there to specify which of the input of your input data you want to use for your computation. This is especially interesting in case you use steering data. This is not our case, so I will just let this function to its default implementation. I will then move on to the next function we need to program. This function is called get input data, and as its name says, it's used to get the pointer to the input data. Well, looking deeper into the code, you will notice that the calculation of the attributes is not done on traces, but using a different object. This is what we call the data order. The data order contains a set of value series, which is basically a series of floats, which holds the value of every sample of the seismic trace. The advantage of this is that in case an attribute has another attribute as input, then this data is already available in the corresponding data order, which saves us a lot of time. Of course, reading some floats from the value series is easier and faster than to get values from the seismic trace. This is the reason why we put this data into the data orders. So let's just continue our attribute by programming the getInputData function. So here we go. The region attribute has a simple getInputData function. We put in our data order. We get the data from our input. And we also get the index of this data, because you might already be aware of that, but we are able to have multiple components in every cube, in every seismic cube, and then this is really important to know which of those components you want to use to compute your data. And this is it. The input data function is already implemented. And I will just move on to the compute data function. Well, the compute data function is, let's say, the core of your attribute. This is where you get the chance to put in there all your mathematics or your algorithm. And this function will be called for every trace. And will loop over every sample we need to calculate. As a remark, I would say that the calculation is made using sample numbers, not time or depth. So let's just try to code for our compute data function. So I started, well, just have a simple condition that if I don't have any inputs, I do not continue. And then I will start doing my first thing. I start by getting the previous sample value. Well, as you can see, this is quite easy to get sample values from your input data. As every attribute is a subclass of the attribute provider, we have already defined in the provider all kinds of MD function that you will want to use during the programmation. And of course, get input value and set output value are amongst all those the functions that you might never forget during the programmation. So how do you use this get input value function? You just set in there your data order. You give it the index of the data. You give it which sample you want to get. In this case, I want to get the previous sample, so -1, and you give it this Z0, which is the start sample where we will start to calculate. It might not seem straightforward, but this Z0 is not always 0. For instance, if your computer has multiple cores, then the computation will be made using what we call multi-threading. This just means that every thread of your computer will just compute one chunk of the trace. So this Z0 can be 0, of course, but can also be sample 24 or 800, depending on the size of your data and the amount of threads that you have on your machine. I continue by computing the current sample value. Same thing. I use the getInputValue function, and my sample index is 0 for the current sample. And then the next thing I will do is just loop over all the samples. Just loop over all samples. Oops. And I will just start by computing the next sample value. As you can see, now the index is my index plus 1. And I will just start with the algorithm itself. First of all, I just do a little check to check whether one of those values is undefined, of course. And then here we go, we just start to check whether we are sitting on a minimum or whether we are sitting on a maximum. And the little algorithm is just as follow. Sorry for the poor. So the algorithm is as follow. If it's a minimum and the region type is minimum or extremes, then we give an output value of 1. If it's a maximum and the region type is maximum or extremes, then we give an output value of 1. Otherwise, we just keep the default value, which is 0. This is basically our algorithm. And the only thing we need to do now is just to set the output value in our data order. Just use the set output value function, specifying in which data order you want to put it, output, at which component, which sample, and of course always this Z0 to know for sure that we are doing well with the multi-threading. Of course, if you follow everything exactly, you will see that I did, omit this, just to be able to continue the loop. And this, and our compute data function is already finished. With this compute data function, that was, I would later on just need to have sometimes some extra information. Sometimes we need additional traces. This is what we call step out, and so we can have desired or required step out. You can have an example of that in our tutorial attribute. And sometimes we also need additional samples. This is actually our case here because we need an extra sample above and we need an extra sample below. As this is a quite easy function, I did already code for it in the header file. This is what you can see here. I have a function called require z-sample margin, and this z-sample margin just requires this small interval variable of the class that I specified in my constructor, one sample above, one sample below. On top of this, you can see this virtual function that is called allow parallel computation. This is the function that specifies that your attribute is entitled for multi-threading. In fact, most of the attributes you will program are entitled for multi-threading, except, of course, attributes that are using recursivity or attributes that requires a transformation of the entire trace at once. Apart from that, all your attributes will be entitled for the parallel computation. And I would say that the most important thing to remember about making your attributes is that the multi-traces handling and the multi-threading are available in an optimized way without the programmer to worry too much about it. the attribute engine is handling everything already for you. So let's just move on to the presentation. So we are now finishing with the algorithm part of the attribute. I will now present you how to create a simple user interface to go with it. I think this is very important to have such a user interface, not only for you, of course, but especially if you want some other user to make use of your attribute. This is always very nice to have an interface and to be able to specify clearly what kind of parameters and input the user wants to put in there. So here you can see a very basic user interface. This is the one of the energy attribute, and I will show you for the reaching attribute how easy it can be to create such a thing. So when we use the user interface to create an attribute description, we need to do basically two sorts of things. The first one is to display in the interface all the data, so input, outputs, parameters that we read from the attribute description. And the next thing we need to do is to retrieve what the user typed, so the new input, the output, and parameters that are chosen by the user, and we need to write them in the attribute description. So what do we do for that? Then we create our attributes interface, and then we have a couple of functions. Among those, set parameters, set input, get parameters, get input, set output, and get output, and the get eval parameters, which is optional. This is optional. This is only if you want to evaluate one of your attribute parameter in a movie style. Again, the set output and the get output are only required if you have more than one output. This is clearly not our case here. So we will just have a limited number of functions that we need to code. So here again, I stop with the presentation, and I will just show you the user interface that we need to the user interface that we want to start. Okay. Yeah, so once again, I did just create for you a basic, I will just put it here so that you can see it easily. I did just create you a basic file for the source file, and let me just pop up the header file. Okay, here it is. Could not find it. So as you can see, the header file is quite simple. A constructor, a destructor, and those functions that we need: set parameters, set input, get parameters, and get input. So let's see what we need to do to create a nice user interface. Well, first of all, I will just initialize the attribute user interface and add it to the factory. This is done via this macro. In this macro, you just specify the name of your plugin, the name of the attribute, the name that will appear in the attribute list, and eventually to which group the attribute belongs to. In our case, I've just classified our reaching attribute into the pattern group. And let's just continue with the constructor. In the constructor, then you can see that we have, if you remember well, we have to do two things. We have to get our input data. This is what I do easily by doing this. I create an input field and specifies whether I'm dealing with 2D data or 3D. And the next thing we need to do is to have a list of the possible choices that we can have, meaning that we need to have a list to say whether we need negative ridges, positive ridges, or combined. So here I just create a general input. I give it next to it the text, choose the ridges to display, so that the user really knows what he has to do. And then I specify a type of the type of the specification, which will be a list of string. Let me just create that little list that will appear in our user interface. That little list will just feature three things: negative, positive, or combined. I have thus created my field. Now you can see here with this line that we can easily just create the frame of our attribute interface by just specifying for each field where we want to attach it and how. So here you just have our field and we say attach a line below the input field, a line below the field that precedes. And when we are finished, which is our case here, but when we are finished with all the parameters and all the fields that we need to have, we usually put this little comment that says that we want to have all our fields aligned nicely below the first one, horizontally. And this is enough for the constructor. This is enough for the constructor. And the next thing we want to do is to continue with this list. And the next thing is the set parameters function. We have one parameter. This parameter is an enum parameter. So what we need to do when we set the parameters is to put the value that we get into the description, to put that in our field, so that the user already knows what is already in the description and gets a chance to change it. Again, this is something that we have tried to make as easy as possible by defining all kinds of macros. So here you want to retrieve a parameter of type enum. Then you get a macro that is called mifget enum. And you would have the same with mifget bool, mifget float, mifget whatever. Again, I will show you later on a little table with the places where you can have all those macros. After the set parameter function, then we need to specify the set input one. Set input function is really easy. In that set input function, we just have to say that we put our input to the input field, and this is it. All the that's just something I forgot to say, basically, but all the user interface that we program for the attributes are UI attribute description editors, and this UI attribute description editor already has all kinds of handy functions. Among those, this put input function to put your input. Let's just move on and continue with the get parameter function. Again, we have something quite straightforward. This is the get parameter function. We have an enum which just retrieve what is in our field, so what is in the type field. We just get the value what is in there, and we just put it into the desk by using this macro and set enum. At last, the last thing we have to do is to get our input. We first process the input that is in the input field, and then we fill the input. We put it in the description. And this is it. We have a nice user interface. So here we have a nice user interface. So now let me just restart with the presentation. So here it is, as promised. Here is a little table on where to find the information. So I've been talking a lot about macro, about parent classes. So if you need to find information about the predefined functions and the functions you need to code to build your attribute, so the functions that are actually in the attribute provider, then you can find that into the attribute engine, into the attribute provider.h file. You have some comments in there to help you getting started. If you need to know more about the different sorts of parameters that you can use, then you can check in the code in the attribute engine and go to the attribute param.h file. Same thing if you need to look for the predefined functions and the function to call to build your user interface. Just go to the UI attribute, UI at desk editor.h file. And if you want to know more about the macros to get or set the parameters in the user interface, just go to the UI attributes param set get.h. I think this is quite straightforward. I guess that you all already know that with the developers package of OpendTect, you have access to the source code, so you can of course see all those files in this specific package, and of course together with a lot of other attributes that are already programmed, and together with our tutorial plugin, of course. So let's just move on. We have a nice attribute. We have a nice user interface for it. What do we do with that? So we'll just show you how to set up a plugin, and later on how to use the attributes in OpendTect. So what do you need to make it be a plugin? If this is a non-UI plugin, so a non-user interface plugin, this is our case, this is our attribute, our reaching attribute, then we need to have two functions. One of the functions is get plugin type, and as you can see, and it's highlighted, the name of the thing that you put in here needs to be exactly the name of your needs to be exactly the name of your folder, of your repository. Okay, and then the plugin type can be early or late. Early is for the attributes, the algorithms themselves. They will be loaded early when we start OpendTect, and late will be for the user interface part. We also need a second function the init plugin, and again you need to make sure that this is really the exact name of your folder that is init. So in our case, init region attribute plugin. And what we do in there is that we just call the init class function. For the user interface, this is the same principle. Get UI region attribute plugin type. In this case, this is late. And the next function we did is init UI region attribute. Again, exactly the name of our folder. Okay, init UI region attribute plugin, sorry. Exactly the name of our repository. And we need once again to call an init class function. So if you have created a plugin, of course you can always load it from the menu, but if you have a plugin that you want to use every day, you might be interested by auto-loading it. How do you do that? Then you can go to your home directory, well, as it is specified here, /.od into plugins, or into the detect application plugins, and you put your .so or DLL name into the .halo file. The halo file stands for autoload file. And you put, of course, the .so library or the DLL itself in libs, in a subdir called libs. There is a protection against multiple load. So, once you have a working plugin, of course you might want other OpendTect users to make use of your new tool. So what you can do is you can always contact us so that we can put our libraries on our FTP, or you can discuss with us the way you want to distribute your plugin, knowing that if you're using the GPL licensing, the software which is developed is per definition covered by the GPL license, or otherwise if you're using the commercial licensing, the software developed can be kept closed source when commercialized. So before we move to the tutorial, to a brief overview of the tutorial plugin, I would just like to show you what we did actually program. So here I start for you OpendTect, and I will just, okay, let me just start one slice, set up one slice, and I start the attribute user interface. As you can see here, you have all the attributes, or you can just subselect a group. In our case, we did put our attribute into patterns, and here it is. This is here the region attribute, and this is exactly what we wanted. We have here a field to specify our input data. Well, in my case, I already have default input data. And here I have my little field saying choose the regions to display, negative, positive, or combined. Let's just choose the positive one. We'll just create the attribute and just apply it. And we have it. We have our region attribute. So all what we've done together was enough to create this. Okay, so let's come back to the presentation for the last few slides. So just a word about the tutorial plugin. If you want to go further, then you can have a look at it. In there you will have examples of UI and non-user interface tasks. And it gives good examples of how to set up the plugin, how to add the menus, how to create a simple attribute with the attribute tutorial, how to access seismic data, to access objects, and to add help pages, which can be also pretty handy. As conclusions, I would just say that turning your algorithm into an OpendTect attribute is relatively easy. This is very easy when we have, as we had today, a very simple algorithm, of course, and it can be a little less easy if you have a very complicated attribute, but anyway, it will always be relatively easy. And creating a simple user interface for your attributes is quick and intuitive. I think that this is also what you can see from the presentation. And of course, for more information, you can have a look at the tutorial plugin or consult our programmer's manual on our website, opendtect.org/rel-doc-programmer. And I wish to thank you all for your attention, and we will maybe start now the question session.
Well, Helen, thank you very, very much. We've been receiving questions as this has been going along as well. And actually, I think we just received one more. Or no, we have a hand raised. I believe we have somebody ready to ask you a question. So I will go ahead and unmute them. Okay, you can go ahead and ask your question, Fidel. Fidel, are you with us? Just a moment. Here, well, we have a question. Fidel, if you can't ask it, I will go ahead and ask it out loud. What version of VC do I need to program a plugin?
Well, if you want to program a plugin, you can just do that with any version. The only thing you need to do is to download the development package. In this development package, you will also have all the source code, all the includes, and then you can start to have a look at all what we already have. And it's most of the time the best way to get started. And of course, you will, with this package, be able to create easily a development environment.
Okay. And we have another question. Let's see, Lirong. I'm not sure if I'm pronouncing that right, but you can speak now.
Yeah. Where to code the program? Can you show us the interface?
Sorry, can you maybe repeat it louder, please?
Okay. I mean, I want to code in some program, so where I should code it? I mean, can you show me the interface, something?
I actually do not use some extra interface. I'm just programming myself on the Linux with a simple VI and GCC compiler, but you can of course also use the Microsoft Visual Studio if you are on the Windows.
But the header file and the header file, the library file has been installed in the computer. I mean, we installed the software. That's what you mean?
The header file that I could present here. This is a header file that I.
I see, but if we download your software and install your software, and the header file and the library file and the DLL file should be installed on the computer, and we just call them, right?
Everything that is part of the software will be already there if you download it. But that also reminds me of something I wanted to do. I do not know whether I can send that to all the participants, but I have here put on our FTP site the code that we the code that I did create for this region attribute. And then you can have a look at how it is done.
Okay. Yeah, I see. So we can use like Microsoft Visual Studio or VRM to generate the plugin, and then we use the OpendTect to load the plugin. I mean, we
yeah, you
generate
can use
plugin.
OpenTect to load the plugin.
Oh.
Either you use the auto load as I here it is,
Yeah,
as I
yeah.
presented in this slide, or if you have OpenTect, console, and if you have OpenTect open, then you can always go to
cool.
Utilities, Plugins, it shows up on the other file, and then just browse to the place where you have your libraries and just load a plugin.
Oh,
Just load
great.
your plugin.
I see. Okay.
I hope
Thank you.
this answers the question.
Yeah, thank you. I got it.
Just a little question.
Yes.
I did send a link to our FTP. I'm not sure whether everybody can see it.
No, not yet. I'm about to make that public, but in the meantime,
yeah.
would you like to explain that? Because we also do have some questions.
Okay, yeah. Just go ahead with the questions, then we can come back to this when it is public.
Okay. Fidel, are you there? Can you speak? Okay. Well, he can't speak, so I'm going to go ahead and ask his question. Can he use Windows 7 for developing the plugins?
Yes, of course. He can also use Windows 7 to develop it.
Okay. And we have one more from Tracy. Tracy, you're unmuted. Can you speak?
I could try. Can you hear me?
Yes.
Yes, we hear you.
I just, to the other person that was talking, you do have to use your PMake facility instead of a standard make to compile the plugins, right? And you've got to run your special source of special code. I forgot what it is now. But,
to source the PMake. Of course, for a matter of time, I cannot, of course, enter in all the details, but you get a lot more information on how to get started with a plugin on the website and into the programmer's manual.
Okay, I was just doing the other person was asking about programming.
Yeah.
And
Thank you.
Just that you can't quite use the standard make. You've got to go through and source the file and environment.
Okay. If you can please check and make sure that the link is correct. I had to retype it. So if you can please check on that.
Well, no, this is not correct. I see that you have a double R into attributes.
Oh, yes.
Apart from that, I think that this is... Yeah, apart from that, it seems correct.
Okay. We have one other person, it appears, that has a question. Let me see. Okay, you're unmuted now. Puyon?
Yeah.
Okay, you're unmuted now. You can speak.
I just like combine different attributes. Can you hear me?
Yes, I can hear you.
Yes, but this is not loud enough for me. Okay, can you try again?
Try again for what? I just combine different attributes in OpenTect.
Okay,
Is it
yeah.
possible?
You mean that you create one attribute that combines a couple of others?
Yeah.
Is that what you mean? Yes, because every attribute can be used as input for the other, so you can have a chain of attributes, as many as you want. This is actually most of the time what we do, for instance, for the neural network, or for this is doable.
I'd like to detect fractures, just fractures. And therefore, you know, there are so many attributes, different attributes which clear and show us the fractures, and I like to combine them for better resolution.
But well, you have of course two ways of doing this. Yes. Do you hear me? Do you hear me?
Excuse me, I missed it.
Okay. Anybody? Do you hear me?
Helen, yes, I hear you.
Okay.
And I could actually hear both of you.
Oh.
Uh-oh.
Oh, I hear a strange noise. Yeah.
Yes.
Oh, I see that we've lost.
I'm going to go ahead and mute him to get rid of that noise. Something strange happened. So, Puyan, if you have another question, can you please type it and I will repeat it out loud? Now we do have another question from Fidel. What compiler do I need to program plugins in Linux-like environments? And yes, he hears you.
Yes. Well, what compiler? The GCC compiler of your Linux installation is just good. I don't know what else to answer. Is it
Fidel? Was that adequate? Okay. Do we have any other questions? I know we have a question that came in earlier that someone was wanting to ask. Oh, here we go. Fidel has another question. Okay. Oh no, he's saying yes. Yes, that was adequate.
Okay. Yeah.
Okay. Okay. Let me. Let's see. Do we have another attendee who has a question? Oh, can I link another library within a plugin?
Yeah, you can actually do that. This is maybe a little bit technical, but you need to have your .a library, and then you need to when you need to create a little plugin to make an interface between this library and OpendTect, so that you can have well, all the needed functions. I mean, like a compute data function is a virtual function and is always needed, so you just have to code a little bit and just, well, call the result that you get in your other library. But yes, this is doable. Well, it depends, of course, what kind of library you want to use, what is the type of it.
Okay.
Anybody?
Let's see. Okay, the link should be updated now. Once again, if you can check that to make sure it's correct.
I think this is correct.
Okay, okay.
I think this is correct. I'm just clicking on it right now, just to check.
Okay. Oh, and I have a response over here that yes, it works.
Okay, this is fine.
And I, at this time, I'm going to go ahead and unmute Nana. He had it was an attendee question that he wanted to repeat.
Yes, there was one question which I think might be the answer might be interesting for the whole audience, and that is if you develop an attribute, if you have to do something different, if you want to work on 2D versus 3D data, maybe you can answer that.
If you want to work on 2D versus 3D data, what? Well, you mean work only with 2D data or only with 3D, or just go from 2D to 3D?
No, if it's so you want your attribute to work on 2D data and you want to have it work on 3D data.
A different way?
Yes, if you have to do something different, if you have to develop something different in your attribute.
No, I would say nothing. Nothing should be different in your coding, except of course if you want to have. If you want to make use of different algorithms. But apart from that, the coding of the attribute itself will just work immediately for 2D and for 3D. If it's if it's just the way your attribute, your algorithm is supposed to work. Well, I'm not sure I'm really clear here.
Yes, I think that's in my answer I said that it's actually the attribute engine is quite intelligent. The attribute engine knows when it's dealing with 2D data or 3D data. So the attribute engine knows from which volume to retrieve and in which order to take all the traces and put them into the attribute. So as a developer, you don't really have to care about 2D or 3D data.
Okay, we have another question that was just sent in. I'm sending it over to Hélène. Do you see this, or should I call it out?
Yes, the question is if you use step out, does it only work on 3D? Well, the answer is no. If you use a step out, it can also work in 2D. You just have to just in your user interface, when you enter the step out, you will just use a field that knows that it is dealing with a step out. That means that the user will be able to enter inline step out and crossline step out in 3D, or just a trace step out in 2D, and then it will be immediately correctly coded in the description and also properly handled in the compute data in all the attribute engine computation itself. Is this okay? Do you hear me?
I hear you. I'm not seeing a response. Oh, yes, and we just received a response that said yes, it was okay.
Okay.
All right. Let's see. Do we have any other questions at this time? Yes, we have another one from Fidel. What modifications do I need to program multi-trace attributes?
With multi-trace attributes, you mean if you want to use a step out? Well, if you want to use a step out, the only different thing you need to do is when you have your get input data, instead of saying input get data, you just have to loop over all the traces that you get and get one by one all the data that you will put nicely aligned into the data order, and that we can use later on in the compute data function. And here, if you use this in the input data, then you will have a loop. Just let me just go to one of our attributes so that you can have a look at how we do it. So I took the example of the similarity attribute, and with the similarity attribute, yeah, I have here the get input data, and the only thing I do different is that for every position I want to get, then I do input get data, and then I specify in there, you see this parameter, I specify in there the relative position of this input data compared to the current trace I'm processing. Here is the relative position. So, well, I won't enter into details with the similarity attribute, but if you have a look at the code, you will just see that this is just the relative positioning of each trace we want to retrieve compared to the current trace. This is basically the only thing you need to do different. Just loop over all the trace, all the position you want to get in. I hope this is enough. Yeah, that's an interesting remark, Nani. I forgot to mention it again. In this case, if you want to have multiple traces, then just don't forget to specify this functions that I mentioned here as extra information. If you need additional traces, just specify a desired or required step out, just to be sure that you will be able to compute at the everywhere in the cube. I mean, if you really need smaller than the actual data that you have, and those functions just make sure that you get the amount of data that you really need. Oops, sorry. Anything else?
Well, if there are no more questions, I don't see any hands raised or any more questions in the question pane. So I'll give you oh, yep, here we go. We have one more. Oh, well, this is a question I've actually received a few questions on, and I can go ahead and answer it. Is the presentation available? Yes, the presentation, the PowerPoint, the code, and the webinar will be made available later on. We'll go ahead and send out an email letting everybody who was part of the webinar know where to find these materials. And if there are no more questions, I'll wait just a moment longer, but if there are no more questions, then I would like to go ahead and thank Hélène and thank our panelists for answering the questions while Hélène was presenting, and thank everybody for joining. This has been a very great webinar, and I'm glad that it was that Hélène was doing this for us for our introductory webinar. This will be the first in a series, and we're going to continue this the first Wednesday of the month for the next 6 months. So please be checking our LinkedIn page and our users mailing list and our web page, and we'll let you know what are the upcoming webinars, and we'll let you know where these will be available online as well. So thank you everyone for coming, and please join us next time.